All right, hello everyone. It's back here again, and with the continuation of the CLT box, and it is definitely growing. Last time around, we only had 4 walls, and we were able to control those walls with certain parameters over here: thickness, half lap width. As you remember, if you haven't seen the first couple videos, these are component-based pieces. Basically, that means that this is one component and includes the half lap already and the lifting hole. So basically, we just create this square or rectangle based off of component pieces, and they are machine ready. Well, kind of. Actually, you would have tolerances in here, but for now, it's pretty good. So we had 4 walls, and I was planning on putting on the slab, which of course you can see is done here, and it also includes the half lap, controlled by the same half lap width over here. So as you can see there, it's adapting. I could, and I probably will make this separately controlled. No, actually, I'll keep it all connected. That's because if it's separately controlled, you actually won't have the overall length of the slab may not match the overall length of the wall below. At the moment, if these two are connected together, then we're always going to have a perfectly square rectangle box. I did have the slabs also going the other way, but it also creates, you basically have to change the arrangement of the walls. So here, the slabs that are spanning this way on the Y, the walls on the X are basically sandwiching the walls inside of the Y. And so if the slabs span the other way, I have to change that arrangement. And I thought about creating 2 different paths, so you can that are controlled by length. So if it goes like above 8 meters, then it starts to span the other way, which could work. But then the problem is when we start to have, spans that are really big in both directions. What rules do we now have for this massive, big old box here? So I decided not to go with that for now, and focus rather on some other things. Let's bring this back. The script is obviously getting a bit heavier, so there's a bit slower. But as you can see, we've got some interesting new features here. We've got some slabs with lifting holes in them, and these lifting holes are controllable. So the hole diameter is connected to the wall hole diameter. So if I just bring that up, you'll see they get super big over there or super small like that. But they have some other sort of functionality here. Let me make this into more of a normal size, 2.5, 2.5. Let's make it 130. Let's increase the height. Let's make it 2.9 meters. And it's a bit more of sort of a standard looking box here. Let's change the half lap width to something a bit more normal. So now we have these really small holes very close to the edge. So if we change the lifting hole to, let's say, 30 millimeters, and here we got the slab lifting hole from the edge offset. So this is like a offset of the slab profile, and there we go. See how that moves? You can move it in. This is all based off of the internal center of mass. So again, a rectangle is pretty easy. It's going to be more or less the center. But you can see there's a slight offset. That's because it's accounting for the half lap. Well, that's what I would assume it's doing. So we have that there. And we also have the distance between the elements that we can adjust there. And if we get super crazy on this, we will... let's change this to a smaller side. You can see it starts to change into 2 lifting holes. Pretty cool. Let's make that big again. So that's basically the functionality of this. It all sort of works really well. You can see the arrangements here and here. The half laps, you can see them there. The other cool thing that's been added is now I've added levels. So here we can see level quantity, and we can start to build our big box. Super easy now that we've defined basically the first kind of structure. And these are of course all parametric. So if I start to, I guess an easy one to see would be the lifting hole. Make that really big. And if I just move that up and down, you can see how it moves on all of them. So that's quite good, and then this can just grow to, you know, whatever size it needs to be. Let's say, make that one bigger. And now you've got this long kind of block. And I've also added some other features, some statistics. Let me show you here. So we've got a bit of a statistics box going on over here. And this is just telling you all the parameters, well, not all, but a lot of the parameters that exist on this box. So we've got the quantities per one floor. And so you can see how this works. If I just reduce this back down to 1, the figures are going to be matching. So total length of walls, total length of walls. This is for the whole building, and this is per floor. Quantity of slab panels, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so on and so on. You can see a total all panel is 42. Yeah, so that's good. And then you've got square meterages, you've got linear meterages. So this is just length on Y. So this is basically your GA setting out, 29 meters by 7 meters that way. And this accounts for end to end. So from there to there on the Y, it's accounting for obviously the thickness of the slab, and it's accounting for the thickness of the wall here. So, you know, you can, if I change this back to 1, we can see something sort of interesting on this. We'd expect that to be, let's say, you know, 3 meters, because there's 3 slabs, but actually it's less than that because of the half lap. Sorry, the overlength will be more than that. So if you look at length on Y, it's 3.22, even though we have 3 panels that are 1 meter, and these are 1 meter. It's just, you know, 1 meter from that lap to there, to there, and to there, and to there. And so our half lap is 0.03, but if we change that to a little bit something easier to 0.05, so 50 millimeters, 50 millimeters. And the wall panels are 160. Let's change that down to 100. And we've got the length on the Y is 3.1. Yeah. Yeah, so that's essentially 100, 200, 3 walls here, but you minus 100. So, yeah, 3.1 basically. And then the same equivalent for this on the X over here. And then when we start to increase the quantity of the levels, you can start to see these building up over here, and it's giving you these overall figures. It gives you the figures of the lifting holes, of the slab area. So 800, this is 108 square meters. Just playing around with this. Total panel counts, we've got 126 counts here, so 126 lifts essentially. And so from this you can build your, you can get statistics from, then you can adapt this into pricing. So you could put a figure against the panel count for lifting. You know, you could say 100, you know, a little formula here, 126 times X amount per lift. And you can kind of build this into a automatic generating cost, which I probably will work on just as a bit of an experiment again. But, you know, my thoughts are now to actually, that I've got this box working in a pretty decent way. I thought, well, you know, what's the point of having a box with no windows or doors? So I will be looking at introducing a system that will essentially punch windows into these openings. And I guess it's going to have to be relative to the size of the panel, just to keep the structure working, the system working well. And the doors are saying punched out, so still keeping to the optimized sizes, but now we're introducing openings. Maybe perhaps I'll look at sort of a beam system, but it could work fine actually. For spanning the other way, it's a bit more intricate. That we'll see how I get on with that one though. So a quick look at the script, if you're interested to see what's going on in there. I think before we pretty much saw these, it was sort of spaced differently over there. The new one is the slab, follows the same principle. It's creating from a rectangle, and the rectangle is arrayed. I went into more detail on this in my second video, so I went into these clusters and showed everything that was happening over here with these things. Essentially, what they're creating, the profiles of the laps. The major difference with this one was creating the lifting tool. So this is the lifting tool for it. It was quite a challenge to figure out how to do it. Let's just make everything a bit smaller here, and I'll show you what I've done. So it was a bit tricky to figure out how to make this work. Maybe there's probably easier ways, but essentially what I did is I created a rectangle that is offset from the external, using the center of gravity as the center point for that. And then I exploded that into individual curves. And then from those curves, I used a system to reduce basically reduce the curves on each edge, and that essentially gave me 2 points that I'm going to use as a 45 degree to my, well, not 45 degree, as a angled towards my center of mass. And that's when I want to move the distance between these apart. That is that's the value that I'm using there. The offset value is how it moves in or away from the center of gravity. And then from there, I just basically added some endpoints and some cylinders that I moved to be a bit more centered to make sure that they're cutting. So at the moment, they're not cutting through the slab there, but I moved them to cut through the slab a bit better. And yep, just used a solid difference to subtract them from each other, and then got all that. And then I created the height system of here really simply using the B-reps from each of the X, the Y wall, and the slabs, and entwining them together to keep the data structure nice, and then just moving them with the system, a simple series, and moving into the Z, and just did a color-coded system as before to match the color code over here. Well, that's it basically. I will continue to carrying evolving this, and I will keep you updated. Great. Well, hope you find this useful, insightful. Let me know if you have any ideas for a CLT box like this. All right, great. Okay, thank you very much. Bye.